Guys, so we talked about system design, right? It's if you look at the first video, and now we are going to look into another system. So for example, you have a taxi, right? You have a taxi here, right? And now what happens is that you have just one people can call you, right? So this is your taxi service that you are starting. People can, this is a phone, right? So what happens is people call you and then you provide taxi service. That's it. This is itself a system. People call and you respond, right? They make a request. You make a request and you respond to them. This is one system. Now what happens is this optimal? Is this scalable? No. This is not scalable at this moment. You're one person and this cannot be scaled, right? More profit you need to generate and more service you need to provide. So what probably maybe as a naive approach, what I will do is I will put two phones. You see, this is all about system design. It's up to you. You are designing the system, right? So this is another phone, and now also request comes in, response, right? It may be a text message, it may be a call. Now the problem is two phones, these are the resources, right? One the resource, two resource. It's gonna cost you as well. So now what happens is that you say, well, you're driving and you're receiving a call and it's not possible, right? So what you do is you ask a friend and you say you wish he or she can help you, and you draw kind of a line in here, imaginary line, right? And your friend receives a call. Now you just have one phone, right? One phone you have, and then you see how it builds progressively, right? So of course you should have some kind of a notebook where you have designed it in a way, times from where to pick up. You see, very primitive system you're building, right? And then you just tell your friend that pick up from this place, drop in this place. Very primitive, right? So well, good. Now what you're gonna do is more people are now requesting, and this person is not enough. So what I do is I might just employ another person, and this person also takes orders and request and response. You see, now the more one thing you have seen is the more you want to scale, the more complications and the more the system will become robust and complex. Now this is our car, and now we see that, well, it's more a problem right now. It's taking more time, right? So for example, we talked about complexity. The more number of the more number of on this y-axis, the time is taking too much time. Maybe linear time, the more it increases by x to the power x or x to the power 2. Anything is okay, like this, right? So good. What can we do? We can get another taxi. Let's get another taxi. See, it will cost you. And now you so now this register will also change. This register will also change because now they have to know which driver. See, they have to send this order to, which means so they will call that specific driver. The problem is they realize that when they randomly call these drivers, they are not in that location. So for example, imagine this is a map. The customer wants to be picked up from here. One taxi is here, one taxi is here. The distance here is less than the distance here. But what this person does, randomly he calls this one because they don't know the location. So they realize, okay, now let's put a GPS so that we know if that person is close to this area, in the vicinity. Like for example, we say if it's in this area, the driver, I'm gonna call the nearest one. So what they do is they just put a GPS device. So now we know the location, which means again they have to constantly record, or at the same time they can constantly see. So this is system. And as we move on, what happens is that now there is more demand. So what to do? There are two. Maybe we'll increase the cars to 3, 4, 5, 6, right? So the more cars we increase in the same city, so now you have cars here, everywhere there is a car moving, right? Now it's much easier if somebody calls from this area. I know these 3 are here. If somebody calls from this area, I know these 3 are here. If somebody calls from this area, I know these 2 are here, and then these can route the call to them. Good. That's all good. So now imagine that the client, when they call in here, remember this, the client, when they call in here to these people, this is like equivalent to what we have in the front end. Uber app, right? Lyft app, or any other app in another country. This is basically the front end. They will have an interface, right? The app is there, you put a search, you have a button, and then you click that button, right? So now it's still a problem. They cannot you have to hire more operators, and then they have to route the calls, and all these things happen. And these 2 registers are like a database, right? They will have database that they will write to, so that we will have data for analytics and all the customer information and payments. And now also we will hire more people that's going to keep track of accounting and all finances. So this is one person and this is another person. So the system is already getting complicated. More people, and this is basically the backend. This is what the backend means. All the business logic is implemented by these people, right? These people, this part, all the business logic is implemented by them. So good. So what happens is that we start thinking about further optimization. So we say, well, the customer may call in. These people have to constantly be in touch with the drivers. The customer calls in, and they may tell a driver that go to this specific area. For example, this driver say go to this area to pick up this customer, and on the way this customer can cancel. Now this person cannot just go over there, so we need a mechanism that can also then they have to double call and they have to call again. You see, this all things is happening. So we need something that does track if the order is active or not active, right? So now this part is our taxi part. These are our fleets of taxis. All taxis are here, right? And that's what Uber did. You cannot just have your own taxi, so people are just going and pitching in. So that means now we need a database. Now I'm going to shift to technical terms, right? A database, their records are here. This will assist this place as well. This is another database, and now we know. Now we also want to know the real-time location of the customers. We said we built an automated backend system that from their phones we know their location, and this is another thing. And another database will be there that will record customer information just like here. So the system is now working pretty okay, right? What else can we do about automation? What else can we automate, right? So you also need to make sure right now that there are taxis available, there are people driving on the road, so they can pick up others, right? So the front end, this is actually the request and response cycle. Customer comes in, they make a request, right? They make a request, it comes to the back end. Your application might be hosted on Linux, that basically these people takes the request is seen, all the data is confirmed, and then they assign a driver, and once the driver picks up, then it's things are and the customer is dropped. This is like a very simple example of how systems can be implemented. So we're going to extend this further more in the next video. Thank you.